Welcome back to enzyme inhibition. This time we will review the equations and graphical solutions for reversible inhibition. To get the most out of the videos, I recommend that you watch them in order. This is a reminder that this presentation is Dr. Johnson's intellectual property. Because the inhibitor and substrate compete for the active site in competitive inhibition, it is harder for the substrate to encounter free enzyme, and the Km appears to increase with increasing substrate concentration. However, once the ES complex is formed, it can proceed with the reaction unaffected. This means that Vmax is not affected, so the lines from all the different inhibitor concentrations intersect with each other at the y-axis of a Lineweaver-Burke plot. This is the distinguishing feature of this type of inhibition. In order for the apparent Km values to be different and have an intersection point at 1 over Vmax, the slopes of the lines at different inhibitor concentrations must increase. The Michaelis-Menten equation for the reaction has a term to account for the effect of the inhibitor on the Km. Alpha Km is the apparent Km in the presence of inhibitor. You can see that alpha incorporates the KIC term. We cannot determine KIC directly from the Lineweaver-Burke plot, so we will replot some of the information from this plot onto a new plot. We typically get the best results if we take the slopes for each different inhibitor concentration to plot as a function of the inhibitor concentration. We now get the negative KIC term from the x-intercept. For uncompetitive inhibition, because the inhibitor binds to the ES complex, formation of the ES complex is not affected. Since there is an additional reaction that the ES complex can undergo, the Km appears to be affected by the inhibitor. Formation of the ESI complex also reduces Vmax as the inhibitor concentration increases. We can see this on the Lineweaver-Burke plot with the parallel lines. The presence of these parallel lines is the distinguishing feature of uncompetitive inhibition. The Michaelis-Menten equation has a modified S term in the denominator to account for the effect of the inhibitor. This time, it does not make sense to plot the slopes against the inhibitor concentration because slope was the one thing that did not change on the Lineweaver-Burke plot. We get the best results if we take the y-intercepts from the Lineweaver-Burke plot to plot against inhibitor concentration in the secondary plot. We obtain the inhibition constant KIU from the x-axis. Don't forget that this will be negative and adjust accordingly. Recall that for mixed inhibition, the inhibitor can bind to either free enzyme or to the ES complex. Therefore, both the Vmax and Km will be affected. The Michaelis-Menten equation incorporates both of these effects. There are two inhibition constants here, KIC for formation of the EI complex and KIU for formation of the ESI complex. When the inhibition data is plotted on a Lineweaver-Burke plot, the lines intersect to the left of the y-axis. The intersection point could be in the quadrant shown here, on the x-axis, or below the x-axis. This intersection point and its location are indicative of mixed inhibition. You will notice that like competitive inhibition, the slopes increase with increasing inhibitor concentration. Since we have two inhibition constants, this time we will make two secondary plots using the same values we used for each of KIC and KIU in the other inhibition types. If you are wondering, isn't there another type of reversible inhibitors, the non-competitive ones? The answer is not really. Technically, this is a subset of mixed inhibition that occurs only in the special case of KIC being equal to KIU, resulting in an intersection point directly on the x-axis. The KIC and KIU terms are determined as for other mixed inhibitors. The term non-competitive suggests that it is not competitive, but then how can such an inhibitor have a term for competitive inhibition, KIC? The historical use of this term includes both the strict definition as given here, as well as other intersection points, and therefore it is not sufficiently precise to convey the correct meaning. Given all these issues, IUBMB states that the term non-competitive should not be used. This wraps up the different types of reversible inhibition. Next time, we'll discuss product inhibition.